Okay, so what we have here is a unit circle, and it gets its name unit circle because it has a radius of 1 unit. So this radius right here, this would be 1 unit. And if you have a point on that unit circle, that point has to be some x value, which is this length right here, and then some y value here. So this is your x, this is your y, giving you this point x, y. And then based on that, we can form a bunch of what we call reference triangles throughout the unit circle, and then we can find the sine, cosine, tangent, and then the reciprocal functions of any angle that's on that unit circle. The unit circle that I gave you in class, this one right here, you can see all of these points, and all of those points are coming from the different right triangles that you can draw. And all of these are our special right triangles, our 30, 60, 90. If I drop it an altitude here, this angle would be 30, the one up here would be 60. Then you have your 45, 45, 90 triangle if I draw here, and then another 30, 60, 90 triangle if I draw here, where the 60-degree angle would be down here. And then those angles just move in different quadrants. So all of the angles in this quadrant, 30, 45, and 60, are the same triangles formed here with this x-axis. And those are going to be called reference triangles. And we're going to use that as a way to find those trig functions of a given angle that's on the unit circle. And so back to our notes. If you notice that taking this triangle right here, this angle here would be our theta. This is my x coordinate, my y coordinate, giving me this point here, the same one that's up here. And then this is my radius. And so based on our whole SOHCAHTOA, we can find the trig ratios for that angle theta. So again, sine is opposite, which is y, over r, that's your hypotenuse. Cosine is adjacent over hypotenuse, so x over r. And tangent is opposite over adjacent, which would be y over x. And then we have our reciprocals. Again, a reciprocal is 1 over the function, or you could just flip it if it's already written as a function. So since the unit circle has a radius of 1, this r now becomes 1. And then we can just rewrite all of these trig functions as what? Well, now I'm sine opposite, which is y over 1, so y over 1 would just be y. So your sine of theta will just be your y coordinate of that point where that terminal side intersects the unit circle. Your cosine theta. Cosine, again, is adjacent over hypotenuse. So that's x over 1. So x divided by 1 is just x. And then tangent theta. Tangent is opposite over adjacent. That will just be your y coordinate divided by your x, and then you just have your reciprocals. So cosecant will be hypotenuse over opposite, secant, hypotenuse over adjacent, and cotangent would be your adjacent over your opposite. So now we're looking at the second sheet of the notes, and it says determine the exact value of the 6 trigonometric functions of the angle theta. And they're telling me that the point where it intersects is 12, 13, 5, 13. 5 13ths. So that would be in the first quadrant. Everyone agreed because x is positive and so is y. So they're saying that this is 12 13ths. This is 5 13ths, and then I can find, how could I find the hypotenuse? Well, I could do the Pythagorean theorem, which again is a squared plus b squared equals c squared. So we'll just call this A and this B, and we're looking for this C. So 12 over 13 squared plus 5 over 13 squared equals C squared. So when I square a fraction, you just square the numerator and square the denominator. So that's 144 over 169 plus 25 over 169 equals C squared. If I add my two fractions, you just add the numerator, the denominator stays the same, so 169 over 169. So C squared equals 1. So we take the square root, we get plus or minus 1, but because we're talking about a length, my C is just 1. So that means this is 1. Well, that tells me that point, 12, 13, 5, 13, is on the unit circle. So if I'm trying to find the sine of theta, you remember from the back, where we just left off, if it's on the unit circle, sine is just going to be your y coordinate. So my sine will be 5 over 13. My cosine theta will just be my x coordinate, so that'll be 12 over 13. My tangent will be my y, which is 5 over 13 divided by my x, which was 12 over 13. Well, we can't leave a complex fraction, so how do you divide fractions? Well, you write the first fraction and then you multiply by the reciprocal of the second fraction. Well, the 13s will cancel and I'll be left with 5 over 12. And then I can easily find my reciprocals. So the reciprocal of 5 over 13 is 13 over 5. The reciprocal of 12 over 13 is 13 over 12. And then cotangent, the reciprocal of 5 twelfths is 12 over 5. Now the next thing we need to do is, they're saying find the 6 trigonometric functions at each real number. So they're saying t is pi over 6. So we're talking about on that unit circle, where is pi over 6? Well, pi over 6, so here's my unit circle. Pi over 6, I'll say is right here. And what is that angle? Most of you are going to want to convert it to degrees. That's 30 degrees. So then I'm just going to make this a bigger triangle. This is 30 degrees, making this 60 degrees, and that's 90. And then you can quickly do our special triangles. This is 1, this is radical 3, and this is 2. And then you can find all the trig values. So sine of pi over 6 would be opposite over hypotenuse. So we're right here is our angle, 1 over 2. Cosine of pi over 6, that's adjacent over hypotenuse, so radical 3 over 2. Tangent of pi over 6, tangent is opposite over adjacent, so 1 over radical 3. And then we rationalize, so we get radical 3 over 3. And then, of course, the reciprocals. I'll put those up here. Cosecant of pi over 6, reciprocal of 1/2 is 2. The secant of pi over 6 would be 2 over radical 3, which when we rationalize would be 2 radical 3 over 3. And then cotangent of pi over 6 would be the reciprocal of 1 over radical 3, which is just radical 3. Now, 5 pi over 4. Where is 5 pi over 4? Well, on the unit circle, if you pull out your unit circle that I handed out, you could look that way. Or, again, a lot of you are going to want to convert this into degrees. But if you remember, here's 0, here's pi over 2, here's pi, here's 3 pi over 2. This is more than 1 pi, and it's pi over 4 more than 1 pi. So that puts this angle in this third quadrant. Because of the pi over 4, that tells you that that is a 45-degree reference triangle. So now we are dealing with the unit circle. We want to look at it this way. That's Probably not a great picture, but here you go. If you remember how to label the sides of your 45, 45, 90, your legs are both 1 and your hypotenuse is radical 2. But because it's in the third quadrant and I am moving to the left, this one has to be negative and this one has to be negative because you're moving left on the x-axis and then down on the y-axis. So that's -1, -1, but your hypotenuse will always be positive. That will be radical 2. And then based on that, you can find the sine of all those angles. I'm going to just call that theta. So sine of theta will be opposite over hypotenuse, so -1 over radical 2, and then we rationalize, so negative radical 2 over 2. Cosine theta, same thing. Cosine is adjacent over hypotenuse, -1 over radical 2, so that will be negative radical 2 over 2. Tangent of theta. Tangent is opposite over adjacent, so -1 divided by -1 is +1. And then my reciprocals. Cosecant will be hypotenuse over opposite, so negative radical 2. Secant will be hypotenuse over adjacent, so negative radical 2. And cotangent will be adjacent over opposite, so -1 divided by -1 is 1. So that's all of those. 0. So where is 0 degrees on the unit circle? Well, that's right here. And what point is that? If this is your unit circle and the radius is 1, this point right here has to be the point 1, 0. So then we're just going to go back and look at, we can't draw a triangle. Since we can't draw a triangle, we are going to be using these ratios right here. So sine's just going to be your y-coordinate, cosine's just going to be your x-coordinate, tangent's going to be y over x, and then the reciprocals, because we cannot draw a triangle. So sine of 0, again, sine will be your y-coordinate, so sine of 0 will be 0. Cosine of 0, cosine will be your x-coordinate, so cosine of 0 will be 1. Tangent of 0, tangent is y over x, so 0 divided by 1, and 0 divided by 1 is 0. And then the reciprocals, cosecant will be 1 over y, well 1 divided by 0 is undefined. Secant of 0, secant will be 1 over the x, 1 over 1 is 1. And then cotangent will be x over y, and that will also be undefined. Next we're at pi. Where is pi on the unit circle? Well, pi is right here. So that point, if I'm going to the left on the x-axis, would be -1, 0. So based on that, I'm going to let you figure out all of those trig ratios for pi. All right, now moving down here, it says find the 6 trig functions at where t is -pi/3. So -pi/3. The negative part tells me which direction am I going to go. Am I going to be going counterclockwise? Is that where a negative angle is, or will I go clockwise? So a negative angle is clockwise. So pi/3, again, many of you are going to want to say, oh, that's -60, so that's going to be down here. So -60. So this angle right here is 60. Here's my right angle. My 30 will have to be here. And then I label my special right triangle. The side opposite the 30 is your 1, side opposite 60 is radical 3, and your side opposite your right angle or your hypotenuse will be 2. Now, because it's in this fourth quadrant, this point right here, I am moving to the right on the x, so this is positive, but however, I am going down on my y, so that radical 3 will be negative. And then now I can find all my trig functions by going opposite over hypotenuse, so sine of negative pi over 3 is negative radical 3 over 2. Cosine of negative pi over 3, cosine is adjacent over hypotenuse, so 1/2. Tangent of negative pi over 3, tangent is opposite over adjacent, so negative radical 3 over 1 would just be negative radical 3. And then my reciprocals. So cosecant of negative pi over 3 is hypotenuse over opposite, so negative 2 radical 3 over 3. Secant of negative pi over 3 will be hypotenuse over adjacent, which would just be 2. And then cotangent of negative pi over 3. So negative, the reciprocal of that would be, you would have your 1, your adjacent, over your opposite, and then when you rationalize, you get negative radical 3 over 3. And so this is just the same thing down here, just finding where these values are on your unit circle, and this time you're only finding the sine, cosine, and tangent. So let's try and figure out where all these are. All right. (13 pi over 6). So first of all, 13 pi, if I were to write this as a mixed number, what would that be? Well, it's more than 2 pi. So this is 2 pi, and then another pi over 6. So 2 pi is completely around, and then I need to go another pi over 6. So this is where that is. It's the same thing as pi over 6, which is a 30-degree angle. This is your 60. So 1, radical 3, 2. And you can find all your trig functions. Negative 7 pi over 2. Whoa, negative 7 pi over 2. Where is that? Well, hopefully you realize it's either here or here. Again, if you'd like to make that, you could always find a coterminal angle by adding 2 pi each time. So if I add 2 pi to that, I'd get a common denominator. So I'd get negative 7 pi over 2, and that would be 4 pi over 2, which would be negative 3 pi over 2. Well, that's easier to figure out because this is positive 3 pi over 2, so negative 3 pi over 2 would be up here. And that point right there is the point 0, 1. So that would be the point you were going to use for your sine. Remember, sine is your y, cosine is your x, and tangent is your y over x. Negative pi. Negative pi is pi distance, but going in the clockwise direction. So negative pi is here. It's the same thing as positive pi. That point right there is negative 1, 0. And then again, you can find the sine, cosine, and tangent. So on this one, sine theta, sine is your y, cosine is your x, and tangent is your y over x, which would be undefined. Over here, sine of negative pi would be your y, which would be 0. Your cosine of negative pi would be your x-coordinate, which is negative 1. And your tangent of negative pi would be y over x. So 0 over negative 1, which is just 0. And then the last thing we're going to take a look at is using our calculator. We kind of did this the other day, but just more practice. So you just have to be careful. when I'm putting this in my calculator, you have to decide what mode you're going to be in. So let's take a look at this. Should I be in radians or degrees here? Well, I see a pi over 3, so that's in radians. Here it says cotangent of 1. Again, remember I said if it doesn't have a degree symbol, we assume that's radians. So this would be in radians. Cosine 45 degrees. Degrees, so I need to switch my mode to degree for that one. And secant of 1.8, again, there is no degree symbol, so we assume this is in radians. When we type these into our calculators, you will just type this exactly how you see that. So if I pull my calculator out here, turn it on, again, I'm going to make sure my mode is in radians for this one. So radians, I'm going to quit out, and then tangent pi divided by 3, enter. So that would be 1.7321. If I round to the near 4 decimal places, I have to look at that 5. The 5 tells me to round the 0 to 1. Cotangent of 1. Well, remember, we don't have a cotangent button. So in order to put this in your calculator, you're going to do 1 over the tangent of 1. So 1 divided by tangent 1. So 0.642, again 1, because that 0 will round up because of the 9. Cosine of 45 degrees, again I switch my mode. I will be in degrees this time. Okay, so cosine 45, you do not have to put the degree symbol because your mode is now changed. So you can do 0.7071. And then finally secant of 1.8, again we're back in radians. And then you will type in secant is reciprocal of cosine, so 1 over cosine of 1.8. So 1 divided by cosine 1.8 equals negative 4.4014. All right. Now what I want you to do is I want you to fill in this chart. And so you're going to write the sine of 0 degrees, the cosine of 0 degrees, the tangent of 0 degrees, and so on. So again, if we're looking at radians, we look at theta in terms of radians. Zero would still be 0 radians. 30 degrees is pi over 6 radians. 45 is pi over 4 radians. 60 is pi over 3 radians. And 90 is pi over 2 radians. So you can fill in that chart, and we'll talk about that on Monday.